There we go. All right, today's about marginal analysis. And when you see the word marginal, just know that that means that you are going to find the derivative. So we have marginal cost, marginal revenue, and marginal profit functions. And of course, what that means is that you're going to be able to find the slope at exactly one given x value for the cost, revenue, and profit functions. As it says there, the instantaneous rate of change of cost, revenue, or profit relative to some production level or a value of x. Okay, so to go over some definitions, the total cost we know is given by C of x. Marginal cost is given by the derivative of the cost function, C prime of x. And then average cost, this is something you've seen from 1324, is the cost function over x. And then marginal average cost is going to be the derivative of the average cost function. So again, these are functions we've seen before, but now we're just going to take the derivative of them. And it's the same exact setup for revenue and for profit. So revenue, marginal revenue is R prime, average revenue, R bar of X equal to R of X over X, and then you can take the derivative of that, R bar prime of X. And then profit is given by revenue minus cost. We've seen that before. Marginal profit is just the derivative of the profit function. And then average profit, P bar of X is P of X over X, and marginal average profit, P bar prime of X. So those are all the notations and the terms that go with them, or definitions that go with them. Okay. If you just jumped in, here is the file again that we're going over. Marginal analysis. There you go. In the chat. Okay. So again, marginal just means derivative. So now we have our first theorem about marginal cost and exact cost. So the first formula we're given is the exact cost formula. This is if you want to find the exact cost of one item. So this is given by C of X plus 1 minus C of X. This will give you the exact cost of exactly one item. And then we have the marginal cost, which is going to be the derivative of the cost function. The marginal cost function approximates the exact cost of producing the X plus first item. And that formula is given by C prime of X is approximately C of X plus 1 minus C of X. And you can make the similar statements for revenue and profit. Okay, so we just want to practice this marginal cost and exact cost. So with example 1, a company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by C of X equals 10,000 plus 90X minus 0.05X squared. Find the exact cost of producing the 501st fuel tank. Okay, so the way we set that up, zoom in, is for exact cost, to follow the exact cost formula, we're going to plug in to the cost function C of the 501st fuel tank and subtract C of the 500th fuel tank. So we do 501 minus 500, and this will give us the exact cost of the 501st fuel tank. So good rule is whatever number goes in for the second input is always one less than what you're plugging in here. So if that's 501, you'll plug in 500. If it's 502, you'll plug in 501. So it's always one less. Okay, so now we have to take 501 and plug it in for X into the original cost function. and then take 500 and plug it in for x into the cost function, and then this will give us our exact cost. All right, so I have Desmos up. Let's try that out. Okay. Right here. So as it's seen, actually, I'm just going to do this. I'm going to type in the actual cost function. 10,000 plus 90x minus 0.05 x squared. 10,000 plus 90x minus 0.05 x squared. And then I'm going to change it into a table. And this is going to be a lot faster because I'll say 501. And that gives me 42,539.95 minus, and then over here, I'll type in 500, and that gives me 42,500. Okay, and now all we have to do is subtract these two. This is ugly. One moment. Too ugly. 42,539.95. There we go. And when you subtract 42,539.95 minus 42,500, we are going to get that the exact cost of the 501st item is $39.95. Oops, sorry. So that would be the exact cost of the 501st fuel tank. Any questions on that?
No.
Okay.
So just to make sure, I mean, we just always go one less.
That's it.
That's it. Okay.
That's it. Just one less. Okay. And then this wants to know what is the marginal cost. So remember, marginal means take the derivative. So that's what we're going to do first. So for B, we're going to take the derivative of the cost function. So we're going to say C prime of X, and what is the derivative of 10,000? Is 10,000 a constant?
Yes.
Then what's the derivative of
0.
10,000? 0. Good. What's the derivative of 90x?
90.
90. Minus, what's the derivative of 0.05x squared?
0.05x.
Don't forget to bring the 2 down, though.
Oh, yeah.
So 2 times a nickel is how much change?
10.
0.10x. There we go. There's the derivative. And now all we have to do is plug in 501. C prime of 501. And if I'll just use the calculator I have next to me. That's faster. And 90 minus
39.9.
0.10, good, times 501, 39.9.
Okay, so we found the exact cost and then we found the marginal cost, but they're pretty darn close.
Exactly. That's the by theorem, because it says the exact cost and the marginal cost will be approximately equal to each other.
So we're still using the same formula. We're just breaking those numbers down into derivatives, right?
Exactly. So this, I mean, The first one is a longer process because we have to plug it into the original function. But then the second one is the derivative, and it will approximate the cost of the 501st fuel tank just by using the derivative.
Gotcha.
Because what we're saying with all this information is that at the 501st fuel tank, cost is increasing by $39. That's what we're saying.
Oh, okay.
So anything after the 501st is going to be more expensive.
And it's only at 501 then.
Only at 501. Now, if
So
you
that's
typed
like
in
the sweet area. Sweet
for
spot.
now, right? So if it also depends on if there's a revenue function or profit function. Because if we're making X amount of fuel tanks, but we're selling them at a higher price, then we could be making more profit. And maybe later on at 1,000 fuel tanks, the price is going down. But this problem just wanted to explore how to find the exact cost and show that marginal cost will get you very, very close to the exact cost.
Mr. C, this is Ryan Van Zandt. I'm gonna try to restart. My computer's giving me issues, so I'm trying to.
Okay. All right. Any other questions on this one? All right. So, so now for number 2, the total cost of producing X bicycles is given by the function C of X equals 10,000 plus 150X. Find the average cost per unit if 125 bicycles are produced. All right, so now we're finding average cost. So this brings you back to your 1324 days, right? So remember that average cost is given by the formula C bar of X, which is equal to the cost function over X. So all we have to do is take this cost function that's already given and put it over X. And then the last step would be to plug in $125. I mean, not dollars, 125 bicycles. So this says, find the average cost per unit if 125 bicycles are being produced. So now we just take 125 and you'll get 10,000 plus 150 times 125 all over 125. Okay, and
Hello?
let's look at this.
Hello.
Hello? You're here.
230.
There you go. You got 230?
Yeah,
Yes, sir.
230.
All right, perfect. Excellent. Let me just do the math. Since this is being recorded anyways, I got to show the math. 10,000 plus 150 times 125 over 125. There you go, 230. So this is the average cost per bicycle if we are producing 125 bicycles. Okay. Now, B says, find the marginal average cost at a production level of 125 units and interpret the results. Okay. So we're going to find the marginal average cost, which means we're going to take the derivative of the average cost function. So let me just zoom back in on the notes. And let's get that handled. So okay, so we'll first start off with our function C bar of X which is 10,000 plus 150x over x. And remember that we can't take the derivative in this form, so we have to split it up algebraically. Well, just like last class, how many fractions can I split this into?
2. Oh, no, 3 actually, right?
2. There's only 2 terms up here, which means you'll get 10,000 over x plus 150x over x. Good with that? And now we must rewrite these. So what's another way to rewrite 10,000x? (10,000x to the what power?
-1 power.
There you go. -1. Plus, what's going to happen to these x's?
Cancel out.
Cancel. 150. Now we are ready to take the derivative of the average cost function. So now we're going to get c bar prime of x. And what is the derivative of 10,000x to the -1 going to be?
-10,000.
Good. -10,000x to the what power?
One.
-2.
Square.
-2. Because remember, you always take 1 away, right? So you go more negative. And then what's the derivative of 150?
0.
0. Look at that. There's our derivative. And now all we have to do is plug in 125. So c bar prime of x is going to be equal to -10,000 times 125 to the -2. All right, and I'll use this blue calculator. -10,000 times 125 raised to the -2. And what do I get?
-0.64.
-0.64. All right. But what does this mean? So remember, derivative is slope. So we're looking to interpret whether this has a positive or negative output and what that means. So our answer was positive or negative?
Negative.
Negative. So this means that when we produce 125 bicycles, the cost is what? Increasing or decreasing?
Decreasing.
Decreasing, right? So when we're producing an average of 125 bicycles, cost is decreasing. Or we'll say the average cost is decreasing. Any questions on that?
I have one, a bit of a dumb question. Sorry. Could you go back and just kind of tell us how you got to, so where you were at the very top first part and it switched to the negative first power? How did you get to there?
How I get here?
Yeah, right there.
Okay, cool. So remember that if you're ever given 1 over x to any power, you can always rewrite it as x to the negative power.
Okay, perfect.
So that's all we did was take that x and flip it up.
And when we have a fraction in there, we still minus it by 1, correct?
Oh, what do you mean fraction? Like as the power or
As the power.
like, so say if it was like 1 over x to the 3/2,
Yeah.
then that would be x to the -3/2. But remember, this is algebra, nothing to do with calculus. All we're doing is rewriting it. So once you do take the derivative, maybe that's what you were talking about, like on this one, you would subtract 1 when you do the derivative. Is that what you meant?
Yeah.
Okay. So yeah, do not confuse rewriting with taking the derivative. That's not the same. This is just rewriting algebraically before you can take the derivative. Make sense? Okay. Okay. So if we're producing 125 bicycles, the cost is going to decrease. And again, there's other factors that could be the reason why your cost is decreasing. Maybe we have the best bicycle on the market and our revenue is increasing. It's beating the cost. That's why it's a negative amount, because our revenue is beating our cost. So these could all be factors, but again, these are just problems practicing, hey, what's the average cost? What is the derivative of the average cost? And what does the derivative mean? And it's important to interpret a derivative as, hey, if it's negative, this means it's decreasing. If it's positive, this means it's increasing. Okay, which brings us to C, which is use the results from A and B to estimate the average cost per bicycle if 126 bicycles are produced. So what do you think we would do here?
We would subtract the 126 from the 125, like we did in the first problem.
Well, this just wants the average cost, not the exact cost.
But couldn't we find the exact cost and then find the marginal cost? Or is that too much work?
That would be, well, would be work that we don't need, because remember, we're not talking about exact cost. We're talking about
Marginal.
average, average cost, right? So there's only a formula for exact cost or exact revenue or exact profit. This problem is all about average cost. So if you look at A, it says if we produce 125 bicycles, it's going to cost us $230, right?
Okay, so you should
But-
just like, divide it by the number of bicycles.
Getting there. So if 125 bicycles cost us $230, and then in B, it says, well, if we produce any more after 230, the cost is going to decrease by 64 cents. So this means that if we want to produce if we want to produce 126 bicycles, well, all we have to do is take the average cost of 125 bicycles and subtract the amount that is decreasing. So we would just say that
30 minus
That's it.
0.64.
that's it. We would say 230, well, not minus, we're going to say plus negative 64 cents. And to produce 126 bicycles, the cost is going to be what?
Be 29.36.
0.36. That's it. And the reason for that is because, remember, look at the slope. It's negative 64 cents. So anything after 125 bicycles, the cost is going to keep increasing by that amount.
Or in this fact, going. Oh no. Yeah. The cost is going down as you make.
As we make more, right? So it's going down by 64 cents. And once again, it's not telling you if there's another factor in here, but we could assume that the reason cost is going down is because of the amount we sell these bikes at. And whatever you sell them at hopefully beats the cost amount, meaning that if the price you sell them at is more than the cost, then of course your cost is going to decrease. Because now you're making more than it is to produce them. Whew. All right. Any questions on that page? So try not to get exact cost and marginal cost mixed up with average cost and marginal average cost. Remember, there's different formulas for those. All right. Any questions on that before moving on? Okay. All right. Hey, look at that. Last one, but the longest one. Look at all those questions. My goodness. All right. So, example 3. A company's market research department recommends the manufacture and marketing of a new headphone set for Apple and Android phones. After suitable test marketing, the research department presents the following price demand equation. X equals 10,000 minus 1,000 P, where X is the number of headphones that retailers are likely to buy at price P per set. The financial department provides the cost function of producing these headphones. C of X equals 7,000 plus 2X, where 7,000 is your fixed cost. It's tooling, overhead, and $2 is the estimate of variable costs per headphone set, materials, labor, marketing, transportation. So our department has already given us information, and now we want to take the price demand equation given above and express the price as P as a function of X and find the domain of this function. Okay, so what we're going to do for A is we're going to rearrange the first equation and solve it for P. And then, based on that equation, we're going to find the domain of this function. All right. So let's do that. X equals, there we go. I'll just write this here. So what we're going to do first, like I said, is solve for P. That looks. There we go. All right, solve this equation for P. So that means the first thing I'm going to move over is that 10,000 to the left. So I'm just going to subtract that to the left. So you'll get X minus 10,000 equal to negative 1,000 P. And then you'll divide everything by negative 1,000. And here you'll get negative X over 1,000 plus 10 equal to P. Okay, but I want to make this look a little better, so I'm just going to change X over 1,000 to a decimal number. And this is going to give us negative 0.001 X plus 10 equal to P. So here's the first part of our answer for A. Everybody good?
How did you change it to a decimal?
Just 1 over 1,000.
Okay.
Negative 1 over 1,000.
Yeah, negative 1 over 1,000.
Okay, got you.
There you go. Okay. And again, the reason we're doing this is to find the domain. We want to find the domain of the function. So we want to put price in terms of X in order to do so. So that's going to be the next part for A. Find domain. Okay. And in order to find domain, well, we have to think of this as a business problem. If price is now in terms of X, well, price can never be below what number?
0.
0. So what we're going to do here is take our new price function and set it greater than or equal to 0. So price can hit 0. We just don't want to go below 0. So we set our domain greater than or equal to 0. All right. And now we plug in what our function P actually equals, which is negative 0.001x plus 10. And now all we have to do is solve for x.
Subtract
So-
10 from both sides.
Good. So I'll move that 10 over.
Yeah.
And then, well, you'll divide by
0.001, negative 0.001.
and here, what happens when you divide by a negative on an inequality?
Negative is positive.
The inequality
The sign.
flips, right? So you'll get x has to be less than or equal to what number?
I'll tell you right now. Let me see. 0.001 should be 10,000.
10,000. Okay. So now, to finish off the domain for this function, we know that we have to be above 0, but now we have to be less than what number?
10,000.
10,000. So what this means is that our domain
We write it. Yeah. Okay.
is going to be from 0 amount of headphones to
All the way to
10,000.
10,000.
So in order to be a profitable company, we have to keep the amount of headphones we produce between 0 and 10,000 sets.
So does that mean that if we get all the way up to 10,000, we will be most profitable?
Not to say that, because you'll see it later in this problem. But like I said, there's a bunch of factors that could be going on, but these are just plain old business problems, right? So
Okay.
let's say that your new headset comes out, you're marketing, you're doing everything right. And in the beginning, you're like, okay, this is great, right? Our profit's increasing, our revenue's increasing. But then now you've made too many sets of headphones, or maybe you need to do more marketing. So now the cost is outweighing your revenue and you'll start to go down.
Oh, okay, okay.
And this is
But-
like the model for any type of function here.
Okay, but somewhere between 0 to 10,000, you're gonna find the sweet area.
You'll
where-
find exactly, you'll find the sweet spot.
Okay.
Yeah. So you just have to make enough headphones to be profitable. So
Yeah.
anywhere between 0 and 10,000. So hopefully we can find that number.
Okay.
All right. So there's our domain. The reason we find that is because it's telling us how many headphones or how much product we have to stay between in order to be a successful company, to be successful at sales. All right. Okay. And now next, B says find the marginal cost function. So what we're going to do is take this cost function and find the derivative. So here, just to have it, I'll write the cost function, C of X equals 7,000 plus 2x. And if you take the derivative of the cost function, this is the marginal cost function. What's the derivative of the cost function going to be?
2x?
Well,
Or- No, I'm
Two.
sorry.
just 2.
Yeah, just 2. Sorry.
Yeah,
Just two.
because
Because the derivative of 7,000 is 0, and the
Yeah.
derivative of 2x is 2. So it doesn't say to interpret what this means, but it'd be nice to actually know what it means other than just having a number there. So again, we took the derivative of the cost function. We now have the marginal cost function, and we have a positive number of 2. So this means that every time we create a headset, the cost is increasing by how much money?
$2.
$2, right? And remember that the derivative and marginal costs, like derivative, marginal, they're all fancy words for slope. Well, if you look at the original cost function, what was the slope of this function?
It was 2x, so it'll be 2.
2, right? So no matter what, it's just telling you, hey, every time you make a headset, it's going to increase by $2 every headset. Not bad, right? All right. Next says find the revenue function and state its domain. So again, we're going back to 1324 and we're going to create the revenue function. And
Profit.
revenue is always given by the amount of items X times the price that we are selling them at. So hope you remember all that 1324, right? All right. So revenue is given by X times the price that we're selling these headsets at. Well, in step A, did we create an equation for price?
Yeah.
It's right there, right? You're going to plug that in for P. Everything's set up for you, right? So you're going to plug in negative 0.001x plus 10. This was P.
But what's the X?
X is the amount of what?
Headphones produced.
Headphones, right? X is just the amount of headphones.
Okay, but it's not
So-
even going to ask us to find that then, huh?
Oh, well, it will. Look at the next one.
Oh, there it is.
All we're doing is finding the revenue function. So let's go ahead and just clean this up by distributing X. And you'll get negative 0.001x squared plus 10x. This is your revenue function.
Do we have to simplify it, or can we leave it just in the
You can
first?
leave it like that. I don't know what my math lab will take. So if it's picky, it's going to take this one. If it's not, it'll take the first one.
Okay.
Yeah. I just expanded out because when you plug in the numbers, it's just easier to calculate with less parentheses.
Okay.
Yeah. Okay. And this said find its domain. Well, if the cost function is going to share this domain, then the revenue function is definitely going to share the same domain. So for all the numbers to make sense, both functions, cost and revenue, are going to share that same domain. So the domain for this function is again 0 less than x less than 10,000. Okay. Everybody good so far?
Yeah. Now we're gonna plug in the 2,000, 5,000, and 7,000. See what we get, right?
Yes, in a moment though, because D says find the marginal revenue function, which means we're going to find the derivative of the revenue function, and then we're going to plug in those numbers. So look at those keywords. So that says marginal revenue, which means it wants the derivative of the revenue function, and then we'll plug in those X values.
Okay.
And of course, we'll interpret what it means. So looking at the revenue function above, we're going to take the derivative. And what is the derivative of negative 0.001x squared?
It's negative 0.001x.
Don't forget to bring them that too.
Oh my goodness. Yeah. You're right.
And then what's the derivative of 10x?
Plus
10.
There you go. And now we'll plug in 2,000, 5,000, 7,000 and interpret the results.
Have your calculator right here.
There you go. So we'll say R prime of 2,000, R prime of 5,000, and R prime of 7,000. Okay. And I'll just calculate these as well. So I'll say negative 0.002x plus 10 Do my little table. Look at that. Beautiful. And 2,000, 5,000, 7,000. All right. And what we get is a positive 6, a 0, and a negative 4. All right. Now, what does this all mean?
I got a quick question. How did we get that negative 0.002x again?
The derivative, right? So we were taking the derivative of the revenue function, which we found here, right? So negative 0.001x squared, that
Fine.
2 comes down, right?
Gotcha. Okay.
All right, cool.
Okay, so if I'm gonna take a quick guess at it, this means that our revenue will increase by 6 when we get to 2,000 AirPods, and then it'll increase by 0 when we get to 5,000.
Well, is
So
0 an
there's no-
increase? Is
so there's
0 an increase or a decrease or neither?
neither. It's just gonna, remain the same. So it's like a constant, I guess you call
Good,
it.
good. Revenue is constant.
Okay, and then at 7,000 AirPods, you're gonna decrease by 4 on that.
There you go. Very good. So what we're saying is that at 2,000 headphones, we're like the new headphone on the market. Everybody wants it, and revenue is increasing by $6 per headphone. And then we are at producing 5,000 headphones, and revenue is still good. Revenue is remaining constant, right? We're still making money. But now we're like, okay, everybody really wants one, so we make 7,000 headphones. But now we have too many headphones out, and nobody wants it anymore because maybe the next company came out with a new headphone, and our revenue starts to decrease by $4.
Wow, that sucks.
Hey, man, that's business, right?
Yep.
It's like the Apple AirPods, right? The beginning, they were like, what, 175, 180, and now they're at 130, and that's just the Series 1, right?
Well, they just came out with the Air Max, which look very ugly, and then so yeah, I think it's following that trend, right?
I still have my Series 1, and it was trying to do the whole kill switch on me. So I just cleaned them real good, and they work better now because they wouldn't hold a charge for a while.
Oh man.
So I just like cleaned everything, and I was like, maybe they're just not a good contact or something, or maybe all my earwax is stuck in the charger.
Same here.
And these are just random X points picked.
Yeah, so this is just from the problem. These are just random X points. So if you want to see the revenue at any other X value, pick a number between 0 and 10,000.
Just plug it in, right?
Yeah, just plug it in and see what it tells you. Because I think if you were to pick 10,000, you'd probably be even more negative, right?
I think so.
10,000 plus 10. Yeah, if I plugged in 10,000, I would get negative 10. So yeah, if we went ahead and produced 10,000 headphones, then revenue would be decreasing by $10. And again, I like to give you a visual of what you're looking at. So look at the revenue function. It is negative x squared. Remember that an x squared function is the graph of a parabola. And if it's a negative x squared function, this means that your parabola opens down.
Yeah, there's a maximum.
So what we're saying is that at this point, which is going to be, we'll call this our 2,000 headphones, your slope is increasing by $6, right?
Yeah.
And then we'll assume that this is 5,000 because now we're rounding out, right? Our money's remaining constant, and you'll have 0 as a slope. And then after 5,000, we see that our slope starts to decrease. We get negative $4, and that's at the 7,000 headphones. So that's what's going on, right? We're good, we're good, we're good. And then we hit the top, and then we're like, oh man, It's our series 1. Let's give out coupons. Let's put it at Costco. Let's do something, right? Let's give some
So,
away for free.
so would it be a pretty good guess if I were to say that when we make, I don't know, I'm gonna say like 4,900 of them, we're gonna have a really like profit, like the max profit that we can make kind of before we flatline?
Yeah, I would assume so. Yeah, because it's right before you just, I mean, being constant, like having a slope of 0 is still good, because imagine that's over like a 2 or 3 year span, right? So money's just constantly coming in,
Yeah,
but I mean, you know it's going to go back down.
exactly.
Okay. Cool. Okay. And the next is graph the cost function and revenue function on the same coordinate system. Find their break-even points and indicate regions of loss and profit. Whew. All right. We're going to cheat code this bad boy, because if we go ahead and try to find the break-even points, it's going to involve the quadratic formula, and this will probably take like 25 minutes. So first thing I'm going to do, though, is label my graph. We already know the x values it's giving us. It's giving us the domain of 0 to 10,000. So that's what I'm going to put here. Down below on my x-axis, this is going to be 0. And then I'm just going to get to 10,000. Let's just do it by 1,000s, right? So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to put that this is in the thousands. Okay. And then for the height, we'll get there in a second. But like I said, let's just go ahead and shortcut this by using Desmos, our best friend. Unless you really, really want to see the quadratic formula, I'll show you. But I'm showing you the faster way out of this, okay? So let me get rid of these. And first thing I'm going to do is put the cost function in, which is 7,000 plus 2x. And then next, I'm going to put in the revenue function, which is negative 0.001x squared plus 10x. And then next, to see everything, I'm going to put our domain down, which is 0 to 10,000. So if you hit this little wrench icon in the top right corner, you can change your domain down here, 0 and 10,000. And then for my y-axis, well, we don't want anything in the negative, so I'm going to start with 0, and let's go, I'll try 100 first. Let's see how that works. And then move this over. Where's everything at? Oh, no, that's too, let's see. Okay, I'll get it in a second. Let's see. I think I had revenue. Let me see where that vertex goes. 0, 10,000. This will be 0. And how about 25,000? Perfect. All right, good. So I picked 25,000. And now we get a better graph. Okay. So when you plot both functions, this is what is great about Desmos, is that it'll give you the points of intersection of the two functions. And if you remember, where the revenue function intersects with the cost function, those are considered your break-even points. So all you have to do is click and look at that, break-even points automatically.
Nice.
And yes, you can do that on a test, because if you go ahead and go the long way, you're going to take forever, right?
Yeah.
All right. So I'll say our break-even points are at 1,000 and 9,000 and 7,000 and 21,000. Okay. And now on my math lab is just going to ask you to pick a graph. It's not going to make you graph everything. So it's going to say, hey, what's this graph actually look like? So just make sure you have your intervals appropriate. Look at my Y values on Desmos. We go up to 25,000. So I'm just going to go by fives on this Y axis right here. So I'll just have 5, 10, 15, 20, 25. I could have made it bigger. Yeah, why not? I have the room. One moment. I'll say skip 5, 10, 15, 20, 25. There we go. Okay, and my cost function is going to go from, let's see, we start at 7,000. So it's going to go and look like this. Here's cost. And then my revenue function starts at 0, 0. And it's going to go up to 25,000 and look something like this. There you go. There's revenue. And now it says to indicate regions of profit or loss. So if you remember, everything inside this lovely little hump here is considered profit. So all of this is profit. And the reason I say that is because, I don't need that, that's ugly, is because revenue is beating the cost function. Everything here is above your cost function, therefore it's profit. And then everything below, down here, I'll do it in red, right? Or I already used red, purple. Everything down here would be a loss of profit. So everything here, those are our regions of loss. Okay. And that is the quick way to shortcut that. All right, everybody good with that? Now, right? Okay, almost there. Next, it says, find the profit function in terms of X. So remember, profit is given by revenue minus costs. So profit is given by revenue minus cost. Well, we have both of those functions, so let's go ahead and use them. So first, to find profit, that's a good color. Profit is revenue minus cost. Now, all we have to do is plug in the revenue function and the cost function and simplify. So revenue is negative 0.001x squared plus 10 minus our cost function of 7,000 plus 2x. Let me make sure I have that right. Good. Cost 7,000 plus 2x. Revenue negative 0.001x squared plus 10x. Don't forget that x. So this should have a x on it. Okay. Distribute that negative. And we'll get our profit function as negative 0.001x squared, and then 10x minus 2x
8x.
plus 8x minus 7,000.
That's it.
There you go. This is profit. Okay. And now, since we have found the profit function, you guessed it, the next problem says find the marginal profit. So you're going to take the derivative of this profit function we just found and plug in 1,000, 4,000, 6,000 and interpret. All right. So we're going to say P prime of X. And what is the derivative of negative 0.001x squared?
It's that one that we did up there, isn't it?
Negative 0.002x, right? And then what's the derivative of 8x?
8,
8. And then what's the derivative of 7,000?
0.
0. There's your marginal profit. And now plug in 1,000, 4,000, and 6,000. Okay. Negative 0.
The first one is 6.
You get 6.
Yeah.
That sounds familiar.
The next one you're going to get, I'll tell you. The next one is 0. And then the very last one, you're going to get negative 4.
Hey, looks like the same numbers, right?
Yeah.
All right. Well, with the same interpretation as the last one, but now we're talking in terms of profit. If at 1,000 headphones, we get a positive 6, this means that profit is what?
Increasing by 6.
Profit increase, right?
Is that $6?
Yep, that's $6 per headphone.
It's not 6 million. I'm just kidding.
No. Those be some expensive headphones.
Yeah, I like the AirPods.
And the second one would mean profit is what?
Consistent, constant,
Good, constant. And the last one?
decreasing by negative 4.
There you go. And that's it, y'all. That is marginal analysis.
All right, sounds good.